morning, my dear grade 11 students. So how are you today? I'm hoping that all of you are doing fine and safe at home. For now, we're going to discuss about standard scores. So class, in the previous lesson, we have discussed about normal probability distribution. So for now, we're going to discuss about standard score. So now class, if you hear the word standard score, so what comes into your mind? Or what do you think about standard score? The standard deviation values at the horizontal base of a normal curve are called the z-scores. We use these scores to specify regions under the curve that we express as probability statements. Now class, when we say z-score, it is a measure of relative standing. It is a standard deviation value. It is the distance between a given value and the mean. Sometimes, it is called a standard score. So it is calculated by subtracting the mean from the specific measurement and then dividing the result by the standard deviations. The z-score locates either within a sample or within a population. Now class, let us discuss about the differential formula of the z value. When z is unknown or the standard score is unknown, the computing formula is the standard score is equivalent into the given measurement minus, of course, our sample mean all over, of course, the sample standard deviation. Then, of course, class, when we are computing or the computing formula may be simplified into, of course, if you are finding for the given measurement, we uses the formula, the product between the z-score and the sample standard deviation plus our mean. Now class, when you are finding for the mean, we uses the formula mean is equals into the given measurement minus the product of our standard score and the sample standard deviation. When we are finding for the sample standard deviation, use the formula, the given measurement minus your given mean all over the standard deviation. So these are some of the formula that we are going to use in other examples. Okay class, for example, you are asked to complete the table wherein you have here the given measurement, the mean, the sample standard deviation, and the standard score or the z-score. For example, you're given is 69 as the given measurement, the mean is 75, the sample standard deviation is 4. So let us find for the z-score. So remember that in finding for the z-score, use the formula, the given measurement minus the given mean all over the sample standard deviation. Okay? And then let's substitute for our given. So the given measurement is 69 minus the given mean is equivalent into 75 all over, okay, all over your given standard deviation, which is 4. So therefore class, what are you going to do? So you need to subtract 69 and 75. So you all know that 69 minus 75 is equivalent into negative 6 all over 4. So negative 6 divided by 4, of course, that is equivalent into negative 1.5. So therefore, your standard score is negative 1.5. Okay class, let us have another example. For example, you are asked to find for the given measurement or your x, wherein your given mean is 45, your given sample standard deviation is 4, and your given z-score, standard score is 1.25. So if you are finding for the given measurement, so you have x is equals into the product between the standard score and the sample standard deviation plus your given mean. So let's substitute for the given value. So your z-score is equivalent into 1.25 to be multiplied by your standard deviation, which is 4, plus your given mean is 45. Then simplify 1.25 times 4, that is equivalent into 5 plus 45. So therefore, 5 plus 45, so we have 50. So therefore, our given measurement is equivalent into 50. So that will be your answer. Next class, let us have the example number 3. You have here the given measurement, the standard deviation, and the z-score. We need to find for our mean. So in finding for the mean, use the formula given measurement minus the product between the standard score and the sample standard deviation. So let us have the given. So your given x is equivalent into 168 minus your z-score is equivalent into 0.4 to be multiplied by the standard deviation, which is 10. So you have 168 minus 0.4 times 10, that is equivalent into 4. 168 minus 4, so we have 164. So 164 is our mean in this given example. The fourth example, 70 as our given measurement, 60 as our mean, and the standard score is 1.25. So let us use the formula S for the sample standard deviation is equals into given measurement minus our mean all over, of course, your standard score. So let us substitute for our given. So our given x is 70 minus your mean is 60 all over the standard score is 1.25. Then let us simplify. 70 minus 60, that is 10 all over 1.25. So therefore 10 divided to 1.25, so we have here 8. So 8 will be our sample standard deviation. Okay guys, so that is how you are going to find for the standard score of a given data. So I hope that you had new learning about the lesson for this day. So if you do have question, please do not hesitate to ask your teacher. So again, stay safe, God bless, and of course, have a nice day.